Geometry Variation and Assessment. This tutorial shows you how to automatically vary geometry by using design variables and design engines in CAESES. At the end, you will be able to browse through your created variants and display the different geometries to find a good design. The geometry that is used during this tutorial was modeled in the previous video, First Modeling Steps. In order to open the geometry, we are going to navigate to the Help section at the bottom of the navigation bar. From there, we click on the menu icon on the top left, then on Tutorials, Basics, and finally we select the tutorial called Geometry Variation and Assessment. Scrolling down will reveal a link named Here, from which you can open the geometry. At first, let's save our new project. After saving the new project, let us navigate to the model workspace through the navigation bar. Click the arrow next to the scope, main duct, to unfold it and use your middle mouse button to make it a working scope. As in this tutorial, our aim is to find a design variant with a minimum volume. We are going to create an evaluation parameter, which will return the volume of the duct without the intake cylinder. We can rename the created parameter to volume and reference the brep, duct closed, by pressing the Alt key while selecting it. Now we can write .getV and press Ctrl+Space to activate auto-completion in CAESES. Select the option Get Volume and convert the expression to cubic meters. Since we don't modify anything else in this scope, let's deactivate the working scope again by pressing the middle mouse button while the cursor is on the scope. To conduct the geometry variation, switch to the optimization workspace through the navigation bar on the left. Different design engines for design variations and optimizations are provided at the top inside the Design Space Exploration section. These engines are able to access and modify design variables automatically and thus create different variants, which can then be analyzed in detail by the user. In this tutorial, we are going to use the design engine, Sobel, to create different variants of the duct. Let's set the number of variants to 15 and select all design variables from the pull-down menu. At the bottom, we select the volume as our evaluation parameter and set the objective to min. You will recognize that the bounds of the design variables are already set, as they were already defined while the geometry was modeled in the previous tutorial. Those predefined bounds can also be varied manually inside the design engine again. To make sure you selected the correct design variable, you can hover over the design variable to reveal its path inside the object tree. Sobel design engines are a pseudo-random number algorithm, which distributes the values of design variables uniformly. This is the reason why it is often used for design of experiments. We can also create screenshots of each variant during the design engine run. To get a good screenshot, switch back to the model workspace and rearrange the position of your geometry to your liking. After deciding on a good position, we go back to the optimization workspace and click on the plus symbol next to screenshots to create a new screenshot collection. A window should pop up where we are going to select 3D view as our desired window for the creation of our screenshots. At the end, we can preview our screenshot before starting the design engine. Let's close the preview window and start the Sobel engine by clicking on the green play button at the top blue ribbon. The created variants are being stored in a design result table on the right. Green scope icons indicate successfully created designs. If the designs encounter any error during the creation, it will be indicated with a red scope icon. You can see that each column contains the values from a design variable or parameter between its specified bounds. Clicking on the head of the column will sort the designs according to the values of the selected design variable or evaluation parameter. The blue scope icon with a star indicates the best design depending on the evaluation parameter, which in our case is the design with minimum volume. You can also click on each design in the design result table to reveal further information. Customizing your own design result table can be helpful if you want to compare certain design variables between certain variants. Let's deselect any object and click on Design Result Table at the top left. Now we can drag and drop design variants into the empty table. Use the search bar at the top left to search for design variables that you want to add to the table. If you found the correct design variable, you can add them again via drag and drop to the table. You can also add designs from different engine runs to compare them in a joined table. Next, let us have a closer look into the design viewer to view the screenshot collection and thus get a visual overview of the created variants. If you want to zoom in or out, you can do this by scrolling the middle mouse button. You can use the bar on the bottom to browse through the different designs. The first row contains your screenshot collection displaying your geometry from the perspective you chose in the model workspace previously. The lower row shows an interactive 3D view. While pressing the Control key, use the mouse buttons to rotate the geometries or zoom in and out. Another helpful feature for displaying the designs is the creation of an animated GIF of your screenshot collection. You can directly create a GIF animation by clicking on the movie icon on the left inside the design viewer. Save the file in your desired location and adjust the frame duration as you like. To view the GIF, open the file from your chosen file location. We can also create 2D diagrams and charts to obtain a better understanding of the correlation between certain design variables and evaluation parameters. These charts can be helpful to follow the progress of the variant creation and your optimization run. To enter the chart view, click on Show Charts at the top left corner of your design result table. Then click on the Edit button and select the design variable icon on the abscissa and the parameter icon on the ordinate. After switching the view to small and deactivating everything else, you can see the influence of each design variable on the volume of the duct. Colors indicate the level of influence. Red colors indicate a positive correlation, whereas blue colors indicate a negative correlation. Green and yellow indicate a rather weak influence. Finally, we can have a closer look into individual geometries. Therefore, click on a design to display its design settings inside the object editor. While the design is selected, you can investigate the 3D model by right-clicking on the gray navigation bar and selecting 3D View. To update to the design, double-click it. The green ribbon above the object tree indicates a different design other than the baseline. Those designs are locked by default, but if you like to modify design variables inside a locked design, click the lock icon. A modified design will be indicated with a gray scope icon and red font inside the object tree. A typical optimization process might start with a simple variation. After browsing through different geometries, we can decide on a good variant and create a new design from it. This might be helpful to clean the project for further design iterations. While the variant is selected, click on New Design at the top left corner. Now, while the design is activated, you can go to the main menu through the navigation bar and click on Save Current Design As. In summary, this tutorial showed you how to run a geometry variation with a Sobel engine, access and evaluate different designs in detail, and lastly analyze the influence of different design variables on a certain evaluation parameter. Thank you for following along, your CAESES support team.